Hi, everyone. I'm Aaron Larson, executive editor of Power Magazine, and today I'm joined by our senior editors, Sonal Patel and Darrell Proctor. And we're going to be covering the September issue of Power Magazine for 2025, giving a preview of all the articles that are covered in the magazine this month. So I'd like to start by talking about our renewable top plants, and that's what's featured on the cover this month. And one of the plants that I worked on a story for was the Desert Power, a deep dive into a massive solar and storage project that's in Nevada. And in this particular project, it was built out in the desert of Clark County, which includes Las Vegas, and it's supplying power to the Las Vegas area. It's a massive facility that at the time of its construction was the largest solar plus storage facility being built in the U.S. It includes 690 megawatts of a photovoltaic array, in addition to a 380 megawatt 4-hour energy storage facility. So it's quite a unique facility that, like I said, was the largest of its kind at the time. It also includes a special direct current coupled storage configuration, which allows the panels to use DC current to charge the batteries, which is kind of unique. And another interesting part of the project was the financing behind it, because it was a $1.9 billion deal. And it was the largest single asset tax equity solar financing ever completed in the U.S. When it was finished. So that was rather unique and an important part of getting this off the ground and installed in Nevada. Other than that, Sonal, I'll turn it over to you to talk about one of the geothermal plants that we featured in the issue and the story you wrote about it.
Yeah, sure. This month's top plant for renewables that I wrote about was in Christine, Texas, which is a town of just 365 people, where San Miguel Electric Cooperative and Sage Geosystems built the first pressure geothermal system. It is a 3 megawatt long duration storage project completed in only 12 months. So in some ways, the South Texas breakthrough is kind of a turning point for geothermal's prospects, given advanced storage and new generation are becoming critical in high demand grids like ERCOT. So Sage leveraged oil and gas expertise, favorable Texas policies, and digital automation. The pilot is set to deliver dispatchable capacity with far fewer geographic or environmental constraints. The geothermal system works like a lung. It is essentially an underground pumped hydro, but upside down, and with added thermal energy, high efficiency, and safety advantages. And so from concept to ready to store in record time is a big deal for geothermal. The project connects to ERCOT in December, and in a grid facing renewable swings, extreme weather, and lots of data center demand. I think it's going to be really something that we're going to be watching going forward. So well-deserved top plant, I think.
All right, thanks, Sonal. And Darrell, you wrote about another solar project in China. Can you talk a little bit about that one?
So the Maidong station in China, it's the world's largest single unit power station, 3.5 gigawatt array, $2.13 billion facility. It began operating in June of 2024. China Construction Engineering Division was in charge of construction, and the China Green Development Group is behind the project. To get a sense of how large this is, some of the folks that I talked to for the article noted that the annual generation from this solar farm is enough to power like the entire city of Houston or Chicago or Toronto, which is just really, mind-boggling when you think about it. It's part of obviously China's continued build out of renewable energy. They dwarf the rest of the world in terms of the amount of renewables that they have online. When you look at just 2025 alone, China added 198 gigawatts of solar power capacity and 46 gigawatts of wind energy. A couple of things that really make the Maidong project, which is located in the Gobi Desert, stand out is the transmission infrastructure that was built along with the solar farm. So they have 208 kilometers of transmission lines connecting the solar farm to various points on China's national grid. China has made a point to build a lot of renewable energy projects in the western part of the country, and they're sending that, hundreds of miles east to the population centers. And Maidong is just the largest of those solar projects to do that right now. So it's really an interesting project to learn about, and just everything that went into it. And yet again, China kind of showing off what that government and that country can do in terms of renewable energy. Aaron, I'll throw it back to you to talk about a hydro project that is actually in my backyard here in Colorado.
Yeah, this is a really interesting one. Thanks, Darrell. And probably the best part about this is the images that XL Energy provided to me, because they have pictures of the plant, which is at an elevation over 10,000 feet in the mountains. And they have them from spring, fall, summer, and winter. And the one I chose to put in the article is actually from the fall, where it's got some beautiful yellow trees in the background, and just really quite a setting.
Those
So
are the aspens, Aaron.
really a beautiful, beautiful area. But what's unique about this project is that it's not new. I mean, this is a plant that was built 60 years ago and it was conceived as kind of a pumped storage hydro facility that would help balance coal-fired generation, because Colorado at the time had really seen a growth in the amount of energy that was being utilized in the state, like a six-fold increase from World War II to 1970. So it was really going through some extreme growth. And this plant was seen as a way to kind of manage the coal plants and allow them to operate more efficiently, maintaining baseload output through nights and down periods, and using the pump storage as a kind of a buffer. Today, it's being utilized more for integrating renewable energy, and some of the facility needed to be upgraded, because after 50 years, you need to do some modernization. And one of the things that they did in XL Energy, in collaboration with GE Vernova, was coming up with a new runner for the units. So they put in an 11-blade runner, which was designed by GE Vernova, and it required a lot of testing and even some new welding techniques, and it was a real improvement over previously existing designs. So that was something that is important for this facility. Some other things that came out during the story is that now it's being utilized more to regulate voltage as a synchronous condenser, which has become a really valuable attribute for a pump storage unit in today's modern world. So, Darrell, I'll turn it back to you to talk about your last top plant story.
Thanks, Aaron. So there's a solar power site in Pennsylvania, and it's been built on a coal mine waste site that had sat abandoned for 80 years. The Sarah Solar Project, it's a 26 megawatt solar farm in Burgettstown, Pennsylvania. And what it shows is how renewable energy development can take place on older brownfield sites. Again, in this case, a waste coal mine site. The innovation here was the tracker system from Nevados, which is a California company that provides equipment for utility scale solar power installations. The terrain of this site was very hilly, would be difficult to build on. So they came in with an innovative tracker system, what they call their Trace all-terrain tracker, and were able to build on this site. It's kind of a model for what can be done on these locations. You're going to need, experience in civil and conservation construction, which is what this company based in Pennsylvania called TerraWorks. That was really a big part of their contribution to the project. One of the things that the advantages gained by using the all-terrain tracker system, it allowed construction on slopes with a 20% degree of elevation. And then they also were able to save a lot of steel because they did a 2% reduction in pile steel density across the site. Again, very interesting to learn more about this and how the site was put together. I think we're going to continue to see more brownfield sites that communities are looking at, and utilities and energy companies looking at, to make something of these brownfield sites, particularly for renewable energy installations.
All right, thanks, Darrell. And then I'll just touch on a few of the other topics that we're covering in the September issue, which includes steam turbines and some of the advancements that have been made in those new technologies being utilized in them. We've also got a submission that came in from Emerson, which is on modernizing control systems and emerging technologies that are being used, and utilizing AI, for example, in some of these new tools. We've also got an article on fuel gas compression for gas turbines to increase pressure and to do it efficiently, whether it's with a screw or reciprocating or a centrifugal compressor. There's an article on water and advancing early warning tools for cooling water intake management. That's an online feature, as well as one on the basic sealing technology for carbon seal rings and how that market is growing. And our commentary this month was on transforming the grid and forging a path to resilience. That came in from contributor G&W Electric. So hope people will check out those articles. And from there, I'll talk about Global Monitor and Sonal, one of the articles that you wrote on nuclear recycling. Can you touch on that a little bit?
Absolutely. So, most of our readers know that for decades, nuclear waste in the U.S. has been treated as an unresolved problem. It has been stored in dry casks, and it is generally seen as a liability. But there's been a new policy push, and the first since the Carter era, actually, is giving nuclear recycling a fresh look. So there are several U.S. companies that are advancing commercial scale concepts to recover valuable fissile material, cut waste volume and heat load, and supply next generation reactors. Globally, France's La Hague plant has reprocessed more than 40,000 metric tons. Japan, Russia, India, and China are also scaling up. And in the US, past reprocessing efforts have stalled really over economics, regulation, and proliferation concerns. In May, the Trump administration, through an executive order, directed the DOE to establish government-owned recycling facilities aiming to secure HALEU supplies for advanced reactors, which is a resource that is really now centered and dominated by Russia. So there are new players that are taking different approaches. Curio is designing a closed-loop system to recover uranium, plutonium, and high-value isotopes, and Oklo is planning to pair their recycling lines with new fast reactors to cut fuel costs by up to 80%, and that's a big deal. Shine is adapting isotope recovery technology for a 100-ton per year pilot, and Orano, which is the world's largest commercial reprocessor, says its proven Purex process could save years of development time. So clearly, I think the hurdles they're still real. And our story goes into enrichment economics, regulatory gaps, to public acceptance. Generally, I think, though, this is really exciting. There's general momentum from experts who are saying, with more emphasis, that recycling could extend fuel resources, reduce repository needs, and the really big one is to improve energy security. So I guess we'll keep watching to see how the U.S. will finally treat nuclear recycling and its effects on nuclear waste.
All right, thanks, Sonal. And Darrell, you wrote a Global Monitor piece on carbon capture. Can you talk a little bit about that and the takeaways?
Yeah, sure, Aaron. So there were a couple of projects that I wrote about. One is in Iceland and the other is in Saudi Arabia. The Iceland project, the start of commercial operation of Stangerroar, a state-of-the-art carbon capture installation. It's transforming Iceland's ON power plant at Hellisheidi, helping capture carbon dioxide in water, permanently storing it as stable minerals within the bedrock. I actually visited this facility in June of 2022 when I was over in Iceland taking a tour of the country's geothermal power stations. And 3 years later, the project is finally underway. The other project is from a Switzerland company called Climeworks, and it's in Saudi Arabia, where they're doing a direct air capture testing unit within CAPSARC's facilities in Riyadh, Saudi Arabia. CAPSARC is a Saudi Arabian kind of an educational group helping with that country's energy industry. So both of these projects, very interesting. Definitely take time to read more about them in our September issue. I'll note in terms of the company CarbFix, which is behind the Silverstone project at Hellisheidi, they made it a point to note also the presence of the Orca facility, which came online in September of 2021, a direct air capture and storage plant, which Climeworks operates there. So, Iceland, obviously, the vast majority of its power comes from the geothermal sector in that country, and they've really been at the forefront of a lot of this carbon capture technology.
All right, thanks, Darrell. And I'll touch a little bit on my Speaking of Power column, which is on solar and wind's hidden costs. And the argument that I spoke with Jonathan Lesser, he's the president of Continental Economics and a senior fellow at the National Center for Energy Analytics. And his argument is that the EIA data that is presented kind of distorts the actual cost that solar and wind feed into the system and make decisions a little bit more difficult to evaluate based on the amount of backup power that's required and different things like that. So it's an interesting argument and something that I think people can learn a little bit about by just checking out that article. So with that, I'll turn it back to Sonal to talk about the big picture, which is interesting again this month. Can you touch on those takeaways?
Sure. So the big picture is an infographic that we put together in our print issues, and typically it is focused on trends. And this month's BP it hones in on REN 21's Renewable 2024 Global Status Report 2025, pardon me. REN 21 is the Renewable Energy Policy Network for the 21st century, and it's basically a global coalition of governments, industry, and research groups that tracks renewable progress worldwide. In 23, renewables hit record highs, but not fast enough to meet climate goals. Global power capacity grew 536 gigawatts last year, 24, a 45% jump from the year before. I think what's takeaway is obviously that fossil fuels are still expanding, and consumption of renewables and of fossil fuels has reached an all-time high. So there is still a substantial climate argument that is sustained here. With renewables, the investment is booming. There was quite a substantial 623 billion invested in 23, but most of it went to just 20 countries, leaving the world underfunded. And I think the big picture basically is focused on how imperatives, including climate goals and carbon taxes, have been implemented, and what is the scale and the impact that they're having on the world.
All right, thanks, Sonal. And with that, I hope everyone will check out our September issue. We've got a lot of interesting content, obviously. Renewable top plants are featured. Also, be sure to check out our website, powermag.com, to learn all the latest news and information that we're reporting on every day. Sonal and Darrell are constantly putting new content up and covering the news. And it's really, I think, a great outlet for people to stay abreast of everything that's happening in the power industry. Also, we're on social media. We've got a LinkedIn presence. We're posting on X, or the former Twitter, and even on Facebook. So check us out, subscribe, and stay abreast of everything that's happening in the power industry. Thanks so much for watching.